All right, welcome. Today, we are going to tackle some concepts that can really trip people up in research: statistical significance, decision errors, effect size, and power. It can feel like you're lost in this maze of jargon, but we're going to turn all of that into a clear, useful toolkit you can actually use. So let's jump right in.
Okay, so picture this. You've run your experiment, you've crunched all the numbers, and boom, there it is on the screen, those two magic words: statistically significant. You're ready to pop the champagne, right? But hold on. The real question, the one that we're going to dig into today, is so what? Did that finding actually mean anything?
All right, so here's how we're going to break this down. First, we'll look at the basic quest for finding an effect. Then, the pitfalls, the two big ways we can mess up. After that, we'll get into measuring the size of what we find and how to give our studies the power to actually see something. And we'll wrap it all up by figuring out the huge difference between significant and meaningful. So let's start with the premise. Think about it. Every study is basically a detective story, right? You've got a hunch, your hypothesis, and you're digging through the data looking for clues. The big challenge is figuring out if you found a real effect or if it's all just random noise, just coincidence.
Okay, so before we can even hope to find the truth, we gotta admit something super important. We could be wrong. In stats, we always start with this idea called the null hypothesis. It's basically the default setting, the assumption that there's nothing going on, no effect. A decision error? That's just when our conclusion about that nothing's going on idea doesn't actually match up with reality. Getting a handle on this is step one to doing any kind of good science.
All right, the pitfalls. How exactly can we be wrong? Well, in this whole detective game, there are basically two major ways we can get led down the wrong path. Let's get into them. Okay, so check this out. On one side, you've got the type 1 error. This is your classic false positive. It's a false alarm. You're shouting, "Eureka!" but oops, there's actually nothing there. Then on the other side, you've got the type 2 error, the false negative. And you could argue this one's even worse. This is when there was a real effect, a real discovery waiting for you, but your study just flat out missed it. The culprit literally got away.
This table really helps make it all click. Look, reality is simple. Either there's no effect, the null is true, or there is an effect, the null is false. And our decision is also simple. We either reject that no effect idea or we don't. So you see where things can go wrong. If in reality there's no effect, but we reject the null, bam, type by error. And if there is a real effect, but we fail to see it, that's your type 2 error. The whole game, really, is to design our studies so we land in one of those correct decision spots.
All right, moving on. Let's say we did it. We ran the study, we avoided those errors, and we got a significant result. We're feeling good. But now comes the next level question. Okay, it's significant, but how big is it? How much does it really matter? And that, my friends, is where effect size enters the picture. I love this analogy. Statistical significance? That's just a smoke detector. It's binary. It just beeps, yes, there's smoke, or no, there isn't. But the effect size? That's the firefighter who runs in and tells you whether you've got a tiny trash can fire or if the whole building's about to go up in flames. It's all about the magnitude. And what's really important is that it's independent of your sample size. So here's what a small effect size actually looks like. See those two curves? They're basically sitting right on top of each other. There's a ton of overlap. Yeah, sure, the average is a little different between the two groups, but honestly, most of the people in both groups look pretty much the same. The effect might be statistically real, but man, is it subtle. But now, check this out. This is a large effect size. The difference is just obvious, isn't it? There's barely any overlap at all. You can look at these two groups and immediately see they are two very different things. This is that clear, strong signal that we're all hoping to find in our research.
You know, the real superpower of effect size is that it's like a universal language for research. Because it's standardized, we can do something really cool called a meta-analysis. We can literally take the effect sizes from, dozens of different studies on the same topic and combine them all together. What that gives us is a much better, more stable idea of what the true effect is out in the real world.
Okay, so we've covered making mistakes and measuring our findings. But let's rewind. What if we could design our study from the get-go to give us the absolute best chance of actually finding something if it's there to be found? And that brings us to the crucial concept of statistical power. The best way to think about power is like the magnification on your microscope. If you have a high-power study, you have a high-tech microscope. You can spot even the tiniest little effect. But a low-power study, that's like using a cheap plastic magnifying glass from a cereal box. The effect might be right there, but you're just not going to see it. Power is simply your study's ability to detect a real effect.
This is so important. Before you run your experiment, before you talk to a single participant, you do what's called a power analysis. It's pretty straightforward. First, you decide on your desired power. 80% is a pretty common goal. Then, you make an educated guess about the effect size you're expecting. Once you have those two things, you can calculate exactly how many people you need in your study to have a decent chance of finding it.
And yeah, sample size is probably the #1 thing that drives power. Let's be real, if your N is 20, you have a low-power study, end of story. You're bringing that plastic magnifying glass to a crime scene. I mean, maybe you'll stumble onto something, but you're really not setting yourself up for success.
But look what happens when we jump up to an N of 200. Whoa. All of a sudden, your power skyrockets. You just ditched the toy and grabbed a state-of-the-art microscope. Now you have a way better chance of seeing what's actually there.
Now, sample size is huge, but it's not the only thing that matters. Your power also depends on, well, the size of the effect itself. Obviously, bigger effects are just easier to spot. And it's also affected by some of the choices you make as a researcher, like what you set your significance level, or alpha, to.
All right, let's put all these pieces together. We've talked errors, we've talked effect size, we've talked power. So what does this all mean when it's time to make the final call on what our research actually found?
And here we are. If you take one thing away from this whole talk, let it be this. A statistically significant result is not always a practically significant one. Let me say that again. Just because your result is significant, which just means it's probably not random chance, that does not mean it actually matters in the real world. That's where this idea of practical significance comes in. It's the so what question. It's asking, okay, fine, the effect is real, but is it big enough to care about? Is it going to change how we do anything? Will it affect a patient, a student, a customer? It's all about the actual tangible impact. And this, right here, is why power is everything when you're trying to make sense of your results. If you run a low-powered study and you find nothing, well, that result is basically useless. It's totally inconclusive. Was there no effect? Or was your magnifying glass just too crappy to see it? You have no idea. But if you run a high-powered study and you find nothing, now that tells you something. That's strong evidence that the effect you were searching for, well, it probably just isn't there. So, I want to leave you with this final thought. As you go forward, ask yourself, what's the bigger mistake for a researcher to make? Is it to raise a huge fuss about a significant finding that's so small it's meaningless, that loud signal about nothing? Or is it to completely miss a quiet signal, a genuinely important discovery just because you didn't have the power to hear it? Really thinking about that, that's what will take you to the next level.